It is given that a uniform rope of length 12 meter and mass 6 kilogram hangs vertically from a rigid support. A block of mass 2 kilogram is attached at the free end of rope. A transverse pulse of wavelength 0.6 meter is produced at the lower end. The wavelength of pulse when it is reached the top of the rope is. So if you are just considering a rope of length 12 meter and mass is given as 6 kilogram. So assume that mass of this rope is 6 kilogram. A block of mass 2 kilogram is attached at the free end of the rope. Now we are attaching a block of mass, let's say 2 kilogram. So here you can say that tension at different points is different. So at this end the tension is because of a 2 kilogram block, let's say that is equal to 20, and tension at this point at over here you can just observe that the weight of the string as well as the weight of block is going to act at this point. So the value of tension at this point is going to be 80 Newton. So tension is different, and the our aim is to find out what happened to the value of its wavelength. So if tension is different, then the velocity will be different, because we know the relation between velocity and tension as V is equal to under root of T divided by mu, and this velocity is equal to frequency into wavelength. So we can say that this wavelength, as frequency is a constant, this wavelength is directly proportional to root of tension. So we can write wavelength in second situation by wavelength in first situation is equal to under root of T2 divided by T1. So wavelength in second situation by wavelength in first situation is equal to under root of the value of T2, that is 80, and the value of T1 was 20. So we'll get as it is nothing but root of 4, or that is equal to 2. So wavelength in second situation is 2 times of wavelength in first situation, and according to the question, wavelength in initial situation is given as 0.06. So the value of wavelength is going to be 0.12.